Hi, nice to meet you again. Today I'm gonna be talking about a fun competitive programming problem called medians. Its hardness is between Usaco silver and gold, and it have a trick which is important for us to learn and interesting. First, let's see the problem statement. Farmer Alexander's n pigs stand in a row. Pig I has the height h of I. Farmer John wants to count the number of intervals I and j such that the interval contains odd numbers of elements, that is, j minus I plus 1 is odd, and the median of h of I plus 1, and all the way to h of j is m. So the inputs are n, h, array, and m. And the output is the number of intervals ij, such that the intervals contains all number of elements, and the medians of h of I plus 1, and all the way to h of j is m. The data constraints are n is smaller or equals to a million. Here's our first hint. Only whether h of I is smaller than m or equals to m or is bigger than m matters. So what only matters is the relative values of h of I relative to m. Thus, we can use -1 to represent a of I smaller than m, and 1 to represent a of I greater than m, and 0 to represent a of I is equals to m. In other words, we define the array a of I as follows. If h of I is smaller than m, we define a of I is equals to -1. If h of I is equals to m, we define a of I is 0. If h of I is greater than m, we define a of I is 1. So we can convert the condition that the median of h of I plus 1, and all the way to h of j is m, to the condition that a of I plus a of I plus 1 plus all the way to a of j is equals to 0. And a of k is equals to 0 for some k between I and j. The second hint is to use a prefix sum. So we define S of I is the sum of a of 1 to a of I. And this is a good point because the condition now can be converted to S of j is equals to S of I. For some I is between 0 and k minus 1, and j is between k and n, where a of k is m. This can be used in our further optimization. The final step is to use a count array. Let's count of value denote how many I between 0 and k minus 1 satisfied S of I is equals to value. And for each j between k and n, the number of S of I such that S of I is equals to S of j is count of S of j. Thus, the final answer is the sum of count of S of j for j between k and n.